did a lab write-up for my physics class. And for those of you who don't know, a lab write-up is essentially the results you publish after doing an experiment. And my experiment used my trebuchet. I'm not going to get into too much detail about what my experiment was, because that's not the point. The point is, I've been really interested in trebuchets. So now I'm going to present to you the top 5 reasons why I like the trebuchet. Number 5. The mere act of building a trebuchet can be intimidating enough to cause enemies to not want to attack you. Now, at some point in the 14th century, when the English were invading Scotland, they were attacking this one city which refused to surrender. So the English decided to build this massive trebuchet called the Werewolf, and upon seeing it, the Scots decided that it would in fact be better to surrender. Now, I probably don't have to explain why I think this is cool, but nevertheless, I'd like to point out that there is another weapon which merely building can be intimidating enough to cause enemies to not want to attack you, and this is known as the nuke. So essentially, the trebuchet is a medieval nuke. Number 4. The limiting factor in the size of a trebuchet's projectile is the strength of a trebuchet's parts. Now, with most siege weapons, like cannons, or artillery, or I suppose even tanks, the limiting factor is the strength of its propulsion method. Like, say for example, we have a cannon that uses gunpowder, and it can only shoot a cannonball of about this size. The reason it can't shoot a cannonball of this size is because the gunpowder isn't strong enough to launch the cannonball. A trebuchet, however, could shoot a projectile of this size, or this size, or this size. The limiting factor there isn't the strength of its propulsion method, it's whether or not that the trebuchet will shake itself apart after it launches the projectile. Number 3. They're relatively easy to build. And I'm judging this by the fact that my dad and I were able to make one. I mean, it's just made out of wood. It doesn't require ceramics or metal, such as a cannon or artillery or tanks. And it doesn't need any specific, like, flexible wood, such as you would for a bow, a crossbow, a ballista, or a catapult. And a catapult also has this bar out front, which stops the swinging arm from going any farther forward. So you also don't need a really tough, strong piece of wood to stop the bar from going forward and destroying the rest of the machine. I mean, obviously you want a relatively strong wood to make it out of, but you don't need any specific, really strong wood or flexible wood. So its components are relatively easy to get, and the concept in making it isn't that difficult either. I mean, it's essentially an off-center seesaw, except at one end you have a bucket, which you fill with something heavy, and at the other end you have a sling. Number 2. It weaponizes gravity. Now, this isn't the first way gravity has been weaponized. That can be credited to falling off a cliff, with the second one dropping something off a cliff. It is the first one, at least as far as I know, that launches a projectile horizontally using gravity. I mean, the fact that it can have something that goes straight downward and just falls, and it can then convert that into a horizontal and rather lengthy horizontal motion, I just think that's really cool. Now, my favorite thing about the trebuchet is the physics behind it. Now, as I mentioned earlier, I became interested in the trebuchet again through a physics lab write-up. So, I was looking at a lot of the physics behind the trebuchet, primarily the acceleration. Now, the trebuchet uses gravity to launch its projectiles, and gravity has a strictly vertical acceleration of negative 9.8 meters per second squared. And if you were to graph this acceleration, it would be constant, i.e. straight line. Now what I found is the trebuchet causes this acceleration to increase by x squared. So, the horizontal acceleration graph, which was originally nothing, would then become linear, or like this. While the vertical acceleration graph would no longer be constant, but it would be exponential. And I just found that really cool. But yeah, hope you enjoyed it. Maybe you even learned something. And see ya!